greatest engineer, the artist, and everything, okay, architect and everything is God. Okay, it's God. So I want to flip through some of God's creation, what God has engineered, how God has made it. You know, it's just it's one of God's work. Okay, just think about it. How can you make a seed? You add the water and the fertilizer, it grow like this. Every flower has its own pattern. Okay, it's beautiful pattern. It's 3D, amazing architecture, and all the color, all the shape. And how did it happen? How can every cell inside the petal coordinate with each other, growing like such a beautiful ball? It's like a monkey face orchard. Okay, how did that happen? And sometimes you do see the sense of humor from God. Am I right? Everybody knows this is the bird of paradise. It's just amazing. How did all the cells inside the flower coordinate with each other, growing a different color, different shape, stick out beautifully like a bird of paradise, basically. This is the flower, the passion fruit. Can you imagine 3-dimensional? All the colors, it's all inside of this flower DNA. Okay, that's why God is such a wonderful engineer, architecture, artist, everything. And you compare all the flower, you wouldn't say which one is better. It's all different. It's all uniquely beautiful. And just like God created all the person with different talent, different personality, we all are uniquely beautiful. We all are uniquely precious inside God's eyes. This is the largest flower in the world. Okay, it can grow up to 10 feet long, 12 feet long. Hummingbird? So how is that possible? And all the metallic color and the surface, the feather, it's just amazing. How God created such a beautiful bird, peacock, and every pieces of it. Look at this, every pieces of it, and all the symmetry. It's just amazing. That's the first question I will ask God when I reach heaven. So how did you do the peacock? It's just amazing. I tried to study the cell structure, DNA, RNA, everything. Okay, but I still couldn't figure out how can it happen. Such a beautiful color, every piece of white feather. So nature is God's creation. That's the definition. Definition of science, discovery of nature. Engineering, application, materialization of science. Okay, so God created the world, have a lot of rule, a lot of the formula, a lot of law, and the science is to trying to find it out. And many times had to be expressed in the mathematics form. Okay, so all the law and the rule, like a gravity law, you can always represent it by a mathematical equation. Okay, and then like a momentum, velocity, gravity, mass, everything. And the engineering trying to apply all this science finding and all the mathematical equation into the real thing. Okay, basic application, materialization of science. Electronics engineering technology, that's a revolution. I really changed the world. So in the last 50 years, a lot of people are talking about the civil rights revolution, talking about the, gay, transgender, all kinds of revolution, talk about environmental protection, all kinds of revolution and all kinds of protests, every corner in the world. But once I read a statement say, the biggest revolution been happening quietly behind the scene is what? It's a high-tech revolution. A lot of electronic engineer, computer engineer, work hard, work quietly, but they've been changing the whole world. Okay, that's what the amazing part of it, big part of this revolution. I started 50 years ago. At that time, the memory, semiconductor memory, they're doing is like a 1K, okay, 1,000 bit. And we thought that's the best of the best at that time. But today, if I'm not wrong, it's the what? 16 gig or 64 gig bit memory. Okay. Can you imagine how many times? 64 million times more than the 50 years ago. And that's a revolution. Let me show you some of the revolution. See, this is Amazon. What do you call? I forgot the name for this shop. Okay, anybody know? Like in the airport, you can see this kind of shop. So basically, nobody working there, and no cashier. You just screen your credit card, you walk in, and you pick up whatever the food you have, you want to buy, or whatever the item you want to buy, you walk out. And then later, you receive the charge about what you bought. How did that happen? They have hundreds of cameras, okay, hang on the wall or in the ceiling and track everybody's move and track every item you pick it up or you put it back. They know exactly everything. So when you walk out, they just charge you your credit card. And hopefully they don't make a mistake. And this is the future shop. This is the face recognition in China. It's the best AI in the whole world, one of the best AI in the whole world. So anywhere you go, any place in China, they know where you are. So one of the American journalists trying to check out the system, so they work with the security department there, police department there, say, okay, I will see how efficient your AI system is. So I'm going to disappear. Right after I walk out of your office, I will see how long it take you to catch me. So he just took the taxi and started driving around and get up there. 7 minutes later, they caught him in the subway station. They say, hey, sir, we got you. So this is how AI works. Okay. So they know exactly your identity by looking at your face, do all the analysis, and all the camera connected to each other. Once they identify you, they just keep tracking you. And this is how the AI works today. Of course, everybody knows GPS. How the GPS works? They have a many GPS satellite there. They send out a GPS signal. So say you have a GPS guided missile. So with 3 or 5 or how many satellites sending a signal, so you're on the ground. And because the different signal have a different angle, so you can analyze this through a lot of mathematical calculation, exactly where you are. So the most advanced military GPS system pretty much can be accurate like I think 10 to 30 centimeter. Okay, 10 to 30 centimeter. So our GPS is accurate to like a 5 to 10 meter, but theirs is 100 times better. Okay, so when they want to hit somewhere, it will hit exactly where it is. So that's how the GPS works. Again, it's the electronic revolution, high tech. Okay. Think about how words have changed. 50 years ago, this kind of a television I had, I think mine was like 18-inch big tube with a speaker there. It's color television. I was so happy. That's a Sony. I said, wow, look at this image. So beautiful. How little I know. Today, like a 60, 80 inches flat panel, and the resolution is like 1,000 times better. But this is a technology change. This is more like a first computer without the vacuum tube. I think it's University of Illinois or somewhere. And this today's computer in your hand. And this computer is about 1 million times more powerful than the first computer 60 years ago, 60, 70 years ago. And this is what happened. And I remember the old time when we traveled to the different places, we all have the map. We keep track and say which street and turn left, and then everybody is watching the sign and everything. And today, it's GPS. I don't think people even know how to read the map. The GPS just lead you there automatically. Now, of course, another 5, 10 years, we don't have to drive the car. We just use the phone to call the needs, and the Tesla going to send a car in front of my door. I get in there, I tell where to go, and then they take me down to the exactly where I go. So maybe another 10, 20 years, nobody need a car. And there's just a lot of public cars. And you just pay and you use it. So you don't have to need a garage anymore. So this is what's going to happen 10, 20 years later. Now, this is technology. Now, who are behind this? I think I have to say it's electronic engineering. Electronic engineering did all this in the last 50 years. So I want to show you what does the electronic engineer really do, okay? From big picture to the detail, a little bit at a time. So at this moment, I'd like to see whether Pastor Lee and Teacher Elaine have any comment for this high-tech revolution. And they all have been through this high-tech revolution and benefit from it.
Go ahead, Pastor Lee.
Go ahead.
Yeah, it is fascinating. Thank you, Teacher Ming, for recap for us. It's kind of walk down the memory lane. And of course, all our teenagers wouldn't fully understand all the ones on the left column because it's like antique and in the museum for you. And yet some of us did see these growing up over the years. So I also did electrical engineering and material science. So it's very much what Teacher Ming is sharing these few weeks on electronic engineering. So I actually did the fabrication, and we can go into that later when Teacher Ming share. And so true. I love how Teacher Ming start with this big picture. Everything, it's God's creation in an amazing way, including all these technology. It's us discovering the nature and God's creation and then using it, designing it to perform functions that would help the society and help our human world to fully enjoy what God has created. So that's such a blessing for us to know. God is the ultimate designer, engineer, creator. He created from nothing to something that we saw in the nature, and then we continue to use the talents that God has given us to make the something into more beautiful, powerful applications in our daily life. So this is going to be a fun journey just to connect the big picture, this endless universe, God's unlimited, infinite power of creation, and yet contained in all the different created, and that we have a part of making designs and application out of it. So that's going to be just a fascinating journey and experience. So for you as teenager, whatever career you may choose, it's all part of that work that I shared a few weeks ago, that we are to manage the created that God has created, and we can partner with God to do it. And just like how you see the electronic engineering history in front of your eyes, you continue to see this evolving. Again, started from nothing that God has chosen to use and then created into the universe, beautiful something. And now we continue to help expand it and be part of God's work into application that we can enjoy every day. Thank you.
Man. Pastor Lee, yeah, I think medical technology see the revolution also because of the electronic improvement. Yeah.
Well, I also started with electrical engineering.
Yeah.
So all three of us share the same backgrounds. But like I always make some bad investment in buying things. I bought the last of the slide rules.
I use
Yeah,
slide
I
rule.
pay.
And the teenager had no idea. I did not even use a slide rule, so I'm
Oh, you
a
did
few
it.
years younger than you.
I did it.
I remember that I paid $50 for a slide rule and has a beautiful leather case like a sword, no? And then I took it to school, and it's sort of like the buying a abacus for the Chinese school, but I did use for maybe one semesters, and then somebody who came to school with an electronic calculator, and it was made by Sanyo. It was the size of a typewriter, and it lights up, and then it would do. And then I was laughing at it and says, "Well, my slide rule is faster than yours." And then my next bad investment was a TI-50 calculator, and that cost me almost like $150 for it. So anyway, technology move on so fast, and you probably know that every time I always buy a computer for $2,000, and then and you know the old computer just sit at home, and then you can look at that and you say, wow, things really change so fast.
That's right. That's right.
But same thing with medical science too. Medical science has evolved so fast that I've been out of it for almost 15 years, and much of it is totally strange to me, because and maybe later on we can invite somebody who can talk about CRISPR and CRISPR. And then you used to talk about genes and mutations, and now you could actually go in and fix it. And so and also the things that I learned 40 years ago in medical school, and we thought it was the gospel, and it turned out they're all wrong. And so everything that we talk about depression today, and it's all people think, but then it's not the truth. And so what I wanted to convey is that there's one thing that is stay constant, and that is God's word, and everything else either move very fast, and new technology, but the understanding sometimes it would be overthrown by somebody who will come out totally different, and it says, hey, same thing with Big Bang. We talk about creations, and then a Big Bang in the last 30 years, 20 years, it was the foremost ongoing. This is the way it happened. But then now that they're saying, oh, well, that it is not. So, all right, fascinating subject.
Thank you for Pastor Lee's comment. I give you one example. I went to implant a tooth. So they took the picture of my tooth, and 3D. So I stand in front of the machine, and they have a 3D scanner in front of me, in front of my head. Then let me take a look at my 3D picture of my skull. It's just like the skull I'm going to be, 500 years later after I die. Nothing there but the skull and the teeth. Just like what you see, in the TV or movie. I said, couldn't believe it. And I said, wow, this equipment must cost you $1 million. Said, no, only $50,000. I said, what? So that's what the electronic technology had done to the human life, Now, of course, all the technology is supposed to help people live a better life and help each other and help all the people get out of the poverty. However, it depends on how people use their technology. So God's purpose is, remember, okay, all this high tech is through the revelation by God. People are creative, nothing wrong with that. But however, if God doesn't reveal a lot of things to the people, God doesn't give the talent to all smart engineers, they're not going to be have an iPhone, they're not going to be a computer, they're not going to be anything. It's all God's revelation, and people work hard on it. So you can always say it's a teamwork between God and the people he created. But his purpose for all the high tech is to help the people live better life and show love to each other, help each other enjoy his nature, enjoy what God has given to us. That's the purpose. Okay, this is God's big plan. So how are we going to use the high tech to bring glory to God? It depends on how closer we are to God. So this is important. So don't forget about the big picture. Okay, and then before I talk about electronic engineer, I like to make a difference. At this moment today, electric engineer and electronic engineer are different. Electric engineer is more generic term. Okay, electronic engineer more specific on people working on the electronic equipment, electronic design, everything. Electric engineer at this moment now more referred to the high power electric engineer, more like electricity, more like a motor control. All this is the high power part of it. So that's electric engineer. But electronic engineer, more people work on the computers, semiconductor chips, radio frequency device, all this. Now I'm going to go through one for you, okay, to show you what does electronic engineering do today. Again, I'm going to use the top-down approach. What is this? This is so-called the tear down of the iPhone, okay, or reverse engineer of the iPhone. So if you open it, actually have a 2 or 3 layer of the so-called printed circuit board, okay. One stack to another, and of course on one side, you gotta have a battery, okay, then you gotta have a display, you gotta have a button, everything. But the most important is you can see all this black stuff. That's the key for today's electronic system, okay? That's the key for the product that all the electronic engineers trying to produce, okay? Including the software engineer, firmware engineer, everything. Because all of this are included in the chips. We call the chips, okay? Or we call IC, integrated circuit. The reason they call it integrated circuit because they put all the circuit inside of this small integrated circuit chips, okay? The outside just you can call the plastic package, but inside there's a silicon chips, okay? Probably in the middle of it, and that have like billions of components, billions of electronic components, okay? Remember I show you this computer, the old time, they use a vacuum tube, okay? One vacuum tube is one component. It's about like maybe small one is more like your thumb, okay? But today, one component is probably 20 square nanometer big. 20 square nanometer big. Compared with like probably 10 square centimeter. Okay, so it's like 1 billion times smaller, 1 billion times smaller. Total scale down in 50 years. Everything, they perform the same function with 1 billion times smaller, and of course, 1 billion times less power. And that's what's so important. So all this integrated circuits, what electronic engineers do. Inside of it has so many components. They have a computer inside, they have a memory inside, then they have a lot of analog signal processing inside. It depends on where the device is and what kind of function is. So if you go down the theoretical functional block diagram, this is what the iPhone looks like. Okay. In a very, very simplified way. So in the left hand, you have a 3 block called the radio frequency processing block. So radio frequency signal. What is radio frequency? Everybody heard a lot about it. Radio frequency. You have a radio, you have a called radiation. Radio frequency basically is a signal God created. Okay. Electromagnetic signal God created can transmit from very far distance. The reason it's very far distance because the frequency is very high. Talking about say 900 megahertz, 1 gigahertz. The human voice is like 20 kilohertz, but their radio frequency is 900 megahertz. Because the frequency is very small, very high, and the signal very small, they can transmit long distance. And that's why our wireless phone can work. Otherwise, our wireless phone cannot work. Same thing, the Wi-Fi. Bluetooth is our radio frequency. And GPS, radio frequency. So the challenge is you have such a small signal. It's so small, it's hard even to describe. Okay, we're talking about signal strength is 10 of the -6. Okay, microvolt. We're talking about microvolt level. But most of the time, our voice is more like a 10, 20 volt level. Okay. So again, it's like 1,000,000 times smaller. But how do you receive that kind of signal? And you can process through it. And that's a big trick. This is called the radio frequency signal processing. And that's what the electronic engineer do for the radio frequency engineer. So this block have a specific expert to do that block. Okay, we call it radio frequency expert. Their whole life is to do the radio frequency. So how can you do it better, more reliable, more robust? Because if the signal coming in, it's not clear, it's not robust, have a noise, then the whole phone is not going to work. So there's a lot of trick here, okay, a lot of trick here. So this is what the electronic engineer do. This is what the radio frequency electronic engineer does. They do a lot of theory analysis, a lot of frequency analysis, a lot of selectivity analysis. Give you an example, like you're in a party. Mom have a 5 years old girl or 3 years old girl in like 100 people's party. A lot of noise and a lot of talking and all different kind of frequency. Suddenly, her daughter is crying out, "Mom, Mom, I need you." But she can immediately recognize and run to her daughter. How is that possible? Well, because her ears and her brain have a special selectivity for her daughter's voice. So there's similar things for the radio frequency. You have to pick up the right frequency, get the signal coming in, then you can do all the processing. But remember, when we talk, our voice actually right on this radio frequency sent to very far away, sent to maybe 100 miles away to somebody. So our voice actually is part of radio frequency signal. And this is another scientific theory. Okay, how do you add one signal into the other signal? See, when I talk to you, I talk to 20 kilohertz. I can shout as loud as I want to. You probably can barely hear me 50 meters from me. Probably 100 meters you cannot hear. But now I want somebody can hear me 100 miles, 1,000 miles away. How do I do it? I put my voice right on this radio frequency in a very unique scientific way, okay, engineering way. And then because radio frequency can travel so far, so the radio frequency travel around, then they reach the other iPhone, and the other iPhone do the demodulation. We call it demodulation. They just pick up my voice and send to the speaker, so the other iPhone can hear it. Okay, so this is very interesting. This whole scientific theory is we call communication theory. Okay, very interesting. All about the processing of the signal, processing of the radio frequency, processing of the audio frequency. How do you mix them together? How do you send them out? How do you bring them back? How do you separate them? And this is what we do for the radio frequency signal and communication engineer. This is called communication engineer. Same thing like for the optical. Think about so much data travel from the optical. It's the same thing. Optical can travel very long distance, okay, without much degradation. So what our trick is, how do we put our audio signal, video signal, right on the optical communication system, optical wave, okay, and then send it to far away without any degradation of the signal. And the fidelity is very good. And this is what all the communication engineers do. Okay, this electronic engineer, major in communication theory, major in radio frequency theory, major in radio frequency circuit design. Okay, so this is the real work created by God, radio frequency signal, the real work created by God. But then God gave us a talent to understand the science background about the communication. Then we need to figure out how to implement the circuit to be able to do that kind of job. Okay? Then look at the right-hand side. Of course, you have a big LCD display. Now you call it the AMOLED display. Then you have a keyboard or touchpad. Then you have a microphone, speaker, earphone. So this all the so-called interface function, human interface function. The human interface function is really interesting. This is what we call the analog world. God didn't create the digital world, okay? God created the analog world. What does the analog world mean? It means every signal we see have indefinite resolution. This is called analog signal. Give you an example. If I give you a light, the light has a luminance level. The luminance level can be 2000 candle, 2001 candle, 2001.1, 2001.11. So indefinite resolution. You keep cutting it, it's always continuous. Same thing like my voice signal. I can say loud and quiet, very quiet. You can barely hear. Indefinite resolution. Okay, this is analog signal. So God only created the analog signal in the world. God didn't create the digital signal. And God gave us human beings the capability to convert the analog signal into the digital domain. Okay, I think everybody understands the binary there. So if I have a 4, magnitude of 4, so 8 to the analog to digital conversion become a 1, 0, 0. Okay, that's 4. Okay, if I give you a signal of 3, and then the analog to digital conversion convert into the 0, 1, 1. Is that right? So I give you a signal magnitude of 1, then you convert it to 0, 0, 1. This is called analog to digital conversion. Okay, so all the analog signal goes through the good analog to digital conversion, can be converted in the digital domain, become a binary signal. So if you have like a 10,000, 100,000 number, I can still convert it into the equivalent binary number. So this is called analog to digital conversion. So like a speaker, like a microphone receive the signal, and then I can convert your voice into a lot of the digital binary stream, and then send to the computer. Because computer is digital, it's binary. So it's not, if it's not digital, it's not binary, the computer cannot process the data. But once I convert the analog signal into the digital format, then computer can do a lot of signal processing. Give you example, like you have an analog, you have a voice coming in, and computer can magnify it 10 times, 100 times, and send it out. And that's called computer signal processing. And computer can mix your voice with your background signal, everything, and do another computer processing. Okay, so the signal processing is all done in the digital format now because computer is fast, it's accurate. Okay, and they can do a lot of things repetitively. And then actually, after the artificial intelligence, I can program the computer to do the face recognition, image processing, a lot of things. But however, computer cannot do anything if they don't have the right signal coming in. The only way the right signal can come in is convert analog signal into the digital signal. And then they can process it, then they can send it out again. Okay, so like a camera, you have a signal coming in, digital camera, you have an analog signal coming in, and goes through the digital camera, decompose into the digital video signal. And then the computer can process in the digital video signal. Then they can send it out to display. Then you can see it. So God gave us all the analog signal. And the human being create a computer, can processing all the analog signal data, and then send it out later. So we can enjoy the signal even better, even more. And we can share all the signal, like YouTube, a lot of video signal, like iPhone camera, a lot of photo, we can share with each other. And then HD TV, Ultra HD TV, and Quad LED HD TV, is all trying to make our eyes satisfy what we see. Can you imagine? With all the high-tech improvement, our eyes still not quite satisfied yet. And this proves how much more intelligent, more power God has created human beings' eyes just to make our eyes to be satisfied with all the video signal we see. I think you all have this experience, Dara. You see a beautiful nature, mountain, trees, sky blue, you immediately pull out the iPhone, take a picture. But then you watch the picture and say, wow, wait a minute. It's not even close to what I see. Am I right? Because we have two eyes, so that's 3D. Now our eyes resolution is very good, and our eyes depth extremely good. There's no way any human camera can catch what we see with our eyes. They keep improving, but there's no way they're even close. And this tells you who's the best engineer in the whole universe. God is the best engineer. God is the best engineer. So this is what the functional block diagram looks like, okay, for the iPhone. Then, of course, you can hook up a lot of external devices, okay. That's why today, like iPhone, you can hook up to the, register machine there. You can hook up the LED lighting there. You can hook up a lot of peripheral devices you want. And this actually give you another, okay, I'm sorry. I can talk about this next time. I think time is up now. So we can have a teacher Elaine and the Pastor Lee give us some conclusive comment.
Yeah, thank you so much, Teacher Ming. This brings back fond memory. This is where I study and I work on. So it's exciting. And I see the teenager really active. A few of you share what you know about what Teacher Ming just showed us. So I'm so glad to see the action and interactions. Thank you, Teacher Ming.